I wanted to go into a little bit more detail looking at multivariate linear programming problems and start to address some of the kinds of issues that you'll run into with regard to our homework that's coming up for this particular unit. And just to throw out one of the examples, this is simply one directly from the textbook. The International City Trust invests in short-term trade credits, corporate bonds, gold stocks, and construction loans. To encourage a diversified portfolio, the board of directors has placed limits on the amount that can be committed to any one type of investment. First of all, the International City Trust wants to put make $5 million available for immediate investment and wishes to do two things: maximize interest. So we already know that we want to maximize our interest. We get 7% from trade credit, 11% from corporate bonds, and 19% from gold stocks, and 15% from construction loans. Actually, I've already completed the entire LP just so I don't waste a lot of time. But you can see in the objective function, I've included all of those different characteristics: 11% for corporate bonds, 19% gold stocks, construction loan 15%. Actually, the next one is they want to make the $5 million available. So we've got 1, 1, 1, 1 has got to be less than $5 million. We're maximizing interest. We want to use all of our $5 million to do that. It gets a little bit more tedious as we look into our next criteria, and that is, in addition, the board specifies that at least 55% of the funds invested must be in gold stocks and construction loans. And the way we've got, of course, X1, X2, X3, and X4. So we've got to make sure for gold stocks, X3, and for construction loans, X4 has got to be greater than the others. And so we set up an algebraic equation. We've got our, again, X1, X2, X3, X4, but our X3 are gold stocks, right here, our gold stocks, and X4, our construction loans, have got to be greater than 55 times our X1, X2, X3, and X4. All we have to do is go through and simply solve that, and we end up with an equation that we can use in our linear program. And that's right here of 55% are going to be in gold stocks and construction loans. So when we solve that equation, we got negative 0.55 plus a negative 0.55 plus 0.45 plus 0.45 has got to be greater than 0. Again, it's just simply solving that equation. Our next constraint that they provided for us is that no less than 15% can be invested in trade credit. And so we set up our equation, and I've actually solved the whole thing right here for you. So trade credit is our X1. So X1 has got to be greater than 0.15 because we want 15 has to be invested in trade credit times X1 plus X2 plus X3 plus X4. We simply, go through, solve for that equation, and we end up with the final equation of 0.85 X1 minus 0.15 X2 minus 0.15 X3 minus 0.15 X4 is greater than 0. We go back to our, and you can see I've already plugged that in right here for our equation. And they also say, and let me go back just to this point, real quick, so that we can look at our last set of constraints. And they say a maximum investment for trade credit is $1 million, $2.5 million for corporate bonds, $1.5 million for gold stocks, and $1.8 million for construction loans. And I've gone through and I've plugged those into our LP as well. So trade credit has got to be less than $1 million. Corporate bonds less than 2.5 million. Gold stocks, gold stocks right here have got to be less than 1.5 million. And lastly, construction loans have got to be less than 1.8 million. We've got all the pieces together. All we need to do is go through and solve it. So I click solve, go down to the problem answers, and you can see right here all of our answers with our objective function, all our constraints. We can say the optimal production model here is 750,000 in trade, 950,000 in corporate bonds. What is this? 1.5 million in gold stocks and 1.8 million in construction loans, for a total profit of $712,000. Again, that's a quick overview of our model here, and thank you very much.